Hey guys, welcome back to the channel. Today we'll be solving some question regarding vector space, and for doing so we what we'll need is these conditions. These are the 10 conditions that should satisfy the phenomenons which are given in the question itself, so as to state whether the condition is followed by a vector space or whether the thing that is given is a vector space or not. So without wasting any time, let's get started. So the first question that we've been given here is whether r square or r cube, whether r square is a vector space or not. So let's check it. So r square is written as x1 and y1. This is the way of writing the r square. Let's take another element, that will be x2 and y2. Now to check whether the conditions are followed by or not, let's take two elements. Let for the addition part. So yeah, for the addition part, let's add these things. So x1 plus x2, and here we will write y1 plus y2. Now if you look carefully, this also belongs to r square. So our this condition is satisfied, addition condition. Now let's talk about multiplication. Okay, so let alpha belong to a real number, and let's multiply this real number alpha with our condition x1 and y1. So what we'll get is alpha x1 and alpha y1. If you look carefully enough, so you'll know what you'll notice is this still belongs to r square. So our multiplication as well as addition condition is satisfied. Now let's talk about other condition. Here u and v. Okay, let's take u as let's take u as x1 y1, and let's take v as x2 and y2. If you add that, what you will get is another vector which will be r square. So this condition is satisfied for the first question. U plus v should be v plus u. That's but obvious that it is also satisfied. U plus v 0. Okay, done. And u plus minus u equals 0, that is inverse, that is also satisfied. And now we have just saw that a dot v also belongs to v, that is a is a part element and v also is an element, and when we multiply that, here a is a real vector, real number. So if when we multiply real number to our condition, that should be also satisfied by the given condition. This is also done. So keeping this all of this thing in mind, we can definitely say that r square is a vector space indeed. Got it? Now the next question is r cube. R cube is written as x1 y1 z1. Okay, now for our proof that so as to check whether this belongs to vector space or not, what we'll do is, first of all, it's a non-empty set. Okay, and then what we'll do is, first of all, we'll try to satisfy the addition condition. Okay, so let's take two elements, that is x1 y1 z1, and add it with let's say x2 y2 and z2. Correct? What we'll get is x1 plus x2 comma y1 plus y2 comma z1 plus z2. Now if you look carefully, this still satisfies that r cube is a real thing. So addition is satisfied. Now let's talk about multiplication. Now if you multiply any real number, that is alpha, with a condition, our condition is x1 y1 and z1. So what you'll get is alpha x1 alpha x2 y1 and alpha z1. Okay, so this multiplication and addition thing is satisfied. Now what we'll have to check is whether 0 belongs here or not. So yes, 0 indeed also belongs to here. If you take all the elements at 0, still the properties are satisfied. Now I'm not explaining it, so just for the sake of the video, otherwise this video will be as long as, let's say, hour and half maybe. So let's skip that, let's understand it orally. Now let's check about the other condition. So as far as the concept is concerned, the umbrella term is if you have satisfied addition and multiplication, then all the other things are not that necessary. I'm not saying it's unimportant, but you can say it's enough. Okay, still these are the condition. If you look carefully enough, if you solve, what you will get is r cube is indeed a real vector. Okay, it's a real vector, 100% real vector. Now let's jump to our third equation. So the next question that is given here is something like this. What it states is that this condition is a polynomial with real coefficients. Okay, with real coefficients. Okay, so again what we'll do is, firstly we will check the addition condition. Okay, so let's take two similar elements which are px and qx. Px, let's say it's a n x n all the way up to a naught, correct? And let's say here it's a m x m, let's say bm, and all the way to b naught. Now what is this? This is nothing but a polynomial equation with the real coefficients. Okay, now let's add. Let's see what will happen if we'll add this. Okay, so when we'll add this px plus qx, what we'll get is a n x n all the way to a naught plus bm xm all the way to b naught. If you look, this whole condition is still a polynomial with real coefficient. So yes, indeed this satisfies this property. So is addition satisfied? Yes, absolutely satisfied. Now let's jump to multiplication. Okay, so let's take alpha as a real number and let's multiply this alpha with the condition, which is p of our condition is a n x n. Okay, sounds great. Now when you multiply is, what you will get is alpha a n alpha x raised to n. This is also indeed still a polynomial with real coefficients. So is multiplication satisfied? Absolutely, it's also satisfied. Is associative and commutative addition satisfied? It's satisfied. What are those? For knowing that, you will have to understand the concept of vector spaces from the beginning. If you have not done, I recommend you to watch the videos regarding that, then you'll get it. So is associative and commutative addition satisfied? Yes. Additive identity, zero polynomial, is that satisfied? Yes, absolutely, that's also satisfied. And the additive inverse, is that satisfied? What it state is just multiply it by -1, that is also satisfied. In the same way, when you'll say is the umbrella term is basically addition and multiplication. Once you have proved that this satisfied, then the remaining conditions are no big deal. Okay, so to answer the question, yes, this is a vector space indeed. Now let's see what the next question is. So this question is again similar to the previous one. The only catch is here the foremost degree is 2, which states that this polynomial is having the foremost degree, the most degree as 2. So to prove that, it's quite basic actually. If you are referred to the previous question, you'll get it easily. You are just so yeah, as I was talking, this question is similar to the previous one. If you have followed that sincerely and with a little bit of attention, you will be easily able to guess what the question is and what the solution is. So as far as the question is concerned, that whether it is a vector space or not, so yes, it's a vector space. Let's move to the next question. Our next question is whether this matrix is a vector space or not. So let's take it. Let's take two matrices as a11 a12 a13 a21 a22 a23, and let's take another matrix as b11 b12 b13 b21 b22 and b23. Now let's add it. Let's check what will happen if we'll just add this two. So what we'll get is a11 plus b11, a21 plus b21, a12 plus b12, a22 plus b22, and a13 plus b13 and a23 plus b23. So is this a 2 by 3 matrix? Yes sir, this is a 2 by 3 matrix, and hence the addition condition is already been satisfied. Let's jump to the multiplication scene. Okay, let's take alpha as a real number and multiply that real number to this a vector, which is a11 a12 a13 a21 a22 and a23. What you will get is this still holds true if M is a 2 by 3 matrix. So is the multiplication condition satisfied? Yes sir, of course it is. Okay, I hope you guys are solving this question. And okay, when I say that addition and multiplication is satisfied, what I meant here is the other condition are already being satisfied. All you need to do is you just need to focus and use your brain. Okay, these questions, all of these questions are already made in such a way that the condition except this addition and multiplication are already satisfied. So if you have successfully justified the condition for let's say addition and multiplication, then boom, you've got your answer. So is this a vector matrix? Yes sir, this is a vector matrix. Let's move on to the next question. Okay, so the next question is X is a non-empty set and the condition is V belongs to F. F is indeed a function which take input from X and gives R as output. So let's check it. So first of all, F here is a function. F is a function which takes values from X to R. So to check addition condition, what we're gonna do is take two similar conditions. Here I'm gonna take fx and gx. Okay, so fx is also x tends to r. Here g is x and tends to r. Now let's see what will happen if we'll just add these two. Okay, so f plus g. Okay, so first of all, f x plus g x will become f plus g, and the common thing is here is x. Okay, now if you look close enough, this condition is indeed being followed by what we have in the question, which means this condition is also true for a function that takes values from x to r. To summarize here, what we have done is we have taken two similar elements fx and gx with the same condition as x tends to r and x tends to r. Then what we have done is we have just added it, and when you add it, what the new condition that you'll get is indeed being followed by the question. So is the addition condition satisfied? Absolutely it is satisfied. Now let's check it for the multiplication scenario. For the multiplication scenario, what we're gonna do is take alpha as a real number and just multiply it. Okay, just multiply it to the condition. When you do so, let's say alpha and a function, and here it's x. What the output is alpha into function of x. If you look close enough, what you'll understand is that yes, this function is also being followed by what the condition in the question is. So is the multiplication followed? Yes, absolutely. So is this thing a vector space? Yes, it is a vector space. Again, keep in mind that the remaining condition are already being satisfied. These questions are made in such a way that the remaining condition except addition and multiplication are already satisfied. So if you have doubt that whether the condition is satisfied or not satisfied, please drop a comment. I'll try to respond it as soon as possible. For now, let's jump to the next question. Okay guys, the next question is q, which is a rational number, is whether a vector space or not. So let's check it. Okay, the answer is no, it's not. How? We'll see here. Okay, so for addition, or let's say first of all the multiplication condition. Okay, when you take alpha, which is a real number, for a specific scenario, let's take alpha as root 2. When you multiply root 2 to a rational number, the result will not be a rational number. Okay, so let me clarify, let me explain what I'm trying to say here. Okay, let's take for the specific condition, let's take alpha as root 2 and q as 1 by 2. So when you multiply alpha into q, which will be root 2, okay, here let's take 3, root 2 into 1 by 3, what you will get here is root 2 by 3. Is this a rational number? No, it's not. Since root 2 is present, so it's not a rational number. So since the multiplication condition is not satisfied, we can say that the q is that is rational number is not a real space. Alright, the last but not the least question is V is a set of all the positive real numbers. Okay, here the catch is the addition is multiplication and multiplication is exponentiation. What do you mean by that? Here specifically for this question, it's a hypothetical situation where a plus b is a multiplied by b and r multiply a is a raised to r. So for this condition, we have to check whether it's a vector space or not. So let's dive into it. For the addition scenario, okay, let's say here a is 2, b is 3 and r is also 2. What we'll have to do is we will just add a plus b and we will multiply it by r. So as you know, here a plus b is basically nothing but 2 multiplied by 3 and dot here is raised to r. So it's 6 raised to 2, that is 36. Is 36 belonging to this set? Absolutely. it is belonging. So is addition is satisfied? Yes, addition is satisfied. Let's talk about multiplication. Okay, let's say alpha is a real number, r, and multiply it by a. Let's say r here is 3 and a here is 2. So r multiply here, the answer will be a raised to r, which is 2 raised to 3, which is 8. So is 8 belonging to this set? Yes, 8 is indeed belonging to this set. So by seeing these two conditions, can we say that addition and multiplication is already satisfied? Absolutely, we can say that. Can we say 0 exists there? Yes, 0 exists there. Can we say identity property is satisfied? Yes, identity property is satisfied. So in conclusion, this is indeed a vector space. Out of all the questions that we have solved, only rational number was not a vector space, except that all of the questions were satisfying the vector space property. I hope that you have got what I am trying to say and you have loved the lecture. Make sure to like, share and subscribe this channel for further updates. Keep hooked in.